In this lecture, we are going to see how we can use this ultrasonic HCSR04 to display the distance on this LCD1602 module. I've explained how to use this ultrasonic sensor, and I've explained how to use this LCD in separate lectures. In this lecture, we are going to combine both, and I'm going to show you how we can use both together to display the distance on the display. Here is the wiring of ultrasonic sensor with this LCD1602. This is the same as initial wiring. Ground have been connected via this gray to the ground. The middle one and this pin echo is connected to pin 11, and then the trig has been connected to pin 12. VCC have been connected to 5 volts. If you're using a breadboard, this VCC of this module can be connected to breadboard and share the same 5 volts, but in this case I've tried not to use breadboard and connecting it directly to pin 2, and I'm setting this pin 2 as 5 volts for this. Ground have been connected here to ground because we have extra ground, and then SD have been connected to pin A4, and SCL have been connected to A5 as always. Wiring, this side that you can see the black have been connected to the ground. The second wire is white, have been connected to pin 2. This is a VCC. And the third one is SDA, that's a gray, have been connected to pin A4. And the pink, the last one, is SCL, the clock, have been connected to A5. For the ultrasonic sensor, ground have been connected to the ground of Arduino here. The echo the pink have been connected to pin 11. The trig, the blue, have been connected to pin 12. And the last pin, VCC, green, have been connected to pin 5. Now let me explain the code. This portion is the same as the original ultrasonic sensor without anything else. The code have been provided. The link will be provided, so you have to download the library. This is part of the library. We are defining these 2 pins, pin 12 for trig pin and pin 11 for echo pin, and this is maximum distance that this can measure. You have to reduce it in order to increase the quality of the measurement. If you don't need higher distance, reduce this. From this class, we are creating an instance, we call it sonar, and we pass these 3 parameters here: trig pin, echo pin, and max distance pin. This also works if I type 12, 11, 200. But that can be managed easily because we can use this within the code later. From this section up to here, this is all for the LCD. Let's first run the I2C scanner. As you can see, the address is 0x3f for this module. Using this class, we are creating an instance, we call it LCD, and address, the number of characters in a line and number of lines for the LCD. To run I2C scanner to find your address, as I've shown you in previous lecture. Here we are creating extra VCC for the LCD because this Arduino has only one 5 volts, so we are creating another pin 2. Inside the setup, we define a serial monitor, so this can display data at 9600 baud, and then we set, using pin mode, VCC2 as an output, so that is pin 2 as an output, and also immediately after that we use digital write VCC2 as high, so this will set the pin high. It will have always 5 volts for LCD. This initializes the LCD.begin and LCD.backlight. It will turn on the right and it clears it, and then we set the cursor at character 0, line 0, and we print this text. It should be 16 characters. Inside the loop, this is a delay. LCD.clear clears the screen because the loop goes and comes back every time, so the previous value from the screen will be cleared. LCD set cursor sets the cursor at line 0, character 0, and we print this text. 0, line 0, and here that's line 1. And after that, this portion is to display this text in here. This 4 line. The first line sets the cursor at character 0, line 1. This is line 0, line 1. And then we print sonar.ping cm. That gets the centimeter distance and prints it for us. Right now it shows 112 centimeter. After that, we send the cursor to character 3, line 1, character 0, 1, 2, and then character 3 is here, and that's line 1, and we print the cm, so it looks nice, centimeter. After that, this portion is responsible for this section. We go to character 7, 0, 1, 2, 3, 4, 5, 6, 7. I put just 2 extra spaces. And then sonar.ping in, that gets the inch distance and prints it for us. And then I realized that with this distance we will never go to 3 digits, so immediately after 2 digits, because this is 7, I started from 9 and print this inches, the text. This portion will print exact same thing that you have seen in previous lecture on the serial monitor. And the loop continues doing the same thing over and over again. Here is a demonstration. The ultrasonic sensor is here, as you can see. It shows the same value that you see on the serial monitor. You will see it also here. And it depends where is the object. If the object is very close, you will see that we are reading 9 centimeter or 3 inches. And if I put it further, you will see that 21 centimeter or 8 inch, and it will give us the value. And here if I put it down, right now it shows 10 centimeter. Even let me point it to the same screen. This was how to use this ultrasonic sensor with LCD1602. Thank you for your attention.